Hello and welcome to E233. I'm your instructor, Gregory Myers. In this video, we're going to take a look at our compare by file function. This video is part of a larger series focusing on our numerical demo and specifically on numerical integration. This video assumes that you have watched the earlier video that was related to the main and the setup of this project, as well as the videos focusing on the left rectangle by file and the similar functions right rectangle by file, mid rectangle by file, and trapezoidal by file. You will need to have all of these completed in order to make this particular example work. Now, if you take a look at our instructions, we were told that essentially we wanted to compare the different methods and to figure out for a given set of data or perhaps a given function, which might be the better function to use or the better method to use rather. Now, this is still an incomplete picture. We've got more work to go, but what we would like to do is we would like to run the 4 methods against the same file name. So essentially our compare by file merely runs the other 4 examples and then attempts to aggregate the output. And particularly if you notice, the goal is that our compare.csv should specify the method, the file name, and the area that was the result of that particular method. So what we want to do is we want to do some preliminary setup and then simply pass along the information to those other functions. So the first thing that you want to do before we go too far is simply delete the results of any previous run. And in this case, I want to remove the left rectangle, mid rectangle, right rectangle, and trapezoidal files, leaving my input_01 and my input_02.csv. Now, let's go ahead and jump into the function itself. And so we're going to navigate, go to the function declaration. And there isn't really going to be a whole lot in the way of error checking that we could do. Technically, we could check to see if the file name was greater than 0. In other words, the length of the file name rather was greater than 0. But aside from that, there is very little that we're going to be doing in the way of error checking in this particular function. So the first step that we want to do is simply create a temporary variable that we're going to call area that we're going to use to simply capture the output of each one of our functions that we call. So our compare by file will essentially make a call to our left rectangle by file, passing the exact same file name. Once again, we could do some preliminary error checking on this file name. From there, what we want to do is we simply want to print out the results to a file called compare.csv for our output. But before we get there, let's go ahead and repeat the process real quick for our right rectangle by file. Our mid rectangle by file. And then lastly, our trapezoidal. Now, we want to go ahead and set up an output file. So to do that, we're going to need an output file pointer. And once again, we can go ahead and hard code this. So we're going to say that our output is equal to fopen, and we're going to hard code the name compare.csv. And we wish to specify that this file is going to be for writing. Before we forget, we want to go ahead and close our output file. So we'll say fclose of output. And now each time we make a call to one of our functions, we simply want to use fprintf to provide a summary of what we've done here. So in this case, we want to specify that we called the left rectangle method. And we want to separate by commas the name of the file name. So %s, and then %f for the area, followed by a new line. And so for the %s, we simply once again specify the file name, and for the %f, the resulting area. At this point, we can simply copy and paste this, making only minor changes to the first column or the method. So first to right, then to mid, and then finally to trapezoidal. The only thing that is left now to do is to create something that looks like meaningful output utilizing our result variable. And by the way, a little minor detail, we have accidentally pushed this part down further. Did not mean to do that. So let me go ahead and move this up to the top of the file again. Now, we want to use the results variable ultimately to return some meaningful output back to the calling function. We can delve into this a little deeper, but at the very least, what we want to do is we want to return the average area for these four methods. And so in this case, what I want to do is I simply want to say results then is going to be equal to some sort of aggregator here. So in other words, what we want to do is we want to sum up the areas. And to do that, we want to create one more temporary variable. We're going to call it area total. And once again, if you capitalize or lowercase, it doesn't really matter. And then each time we make a call to one of our functions, we simply want to add to our area total the area that was recovered from that particular function. So area total is equal to area total plus area. And then the only thing left to do is once you declare the variable and you copy and paste it to each one of the, to capture the area variable after each one of our function calls, is to make sure that you have, in fact, initialized it. So in this case, we're going to initialize area total as equal to 0.0. And then from there, we simply say results is equal to area total divided, in this case, by 4 different methods. Now, there are several issues with this approach. Once again, the assumption is that we're doing some more advanced error checking prior to calling this function. In other words, we're looking at the file name. We're also assuming that the caller and even the user of this application understands when, in fact, we would expect to get a 0 area. In other words, when there is a cancellation between the area above the curve and, the area above the x-axis and the area below the x-axis. So there's a couple of assumptions that we are making here. But once again, we'll delve into those later. For right now, we're simply going to get the average area from each of our methods. At this point, we're going to go ahead and build it. And if we don't have any errors in our code, which we do, let's see what we've done here. Let's see here. Second here. Once again, my classic error here that I forget routinely to include my output file pointer. And I genuinely do not know if I am ever going to get over that. I seem to do that countless number of times in every language that I use. All right, so let's go ahead and build it. Okay, let's go ahead and clear our screen. We'll check our directory. You'll see that all we have are our input files. And now what we would like to do is we would like to call our numerical demo, parametric mode, and We want to call the compare function. We want to do it by file. And more importantly, we want to compare it against our input underscore o1.csv. And if we hit enter, you'll notice that we had a considerable amount of data fly by. Well, effectively what's happened is we have opened that input file 4 different times, printed the results 4 different times by virtue of calling each one of our methods. And we can also verify that this is what happened because if you see up at the top, it actually specifies which methods were called. Now, at this point, you can decide if you want to eliminate the printf that prints out our data, or if you feel that that is helpful. You can also type in dir, and you'll notice that the artifact of each one of our function calls were those CSV files. So there's the left rectangle, the mid rectangle, the right rectangle, and the trapezoidal. And all of them have data in them. So far, this looks very promising. But the file that we are now interested in is this compare.csv. And so what I'd like to do is I'd like to open this in NetBeans, and sure enough, you'll see there is the results of our 4 different functions, our 4 slightly different methods for numerical integration. At this point, you should feel like you've got a pretty good start on concepts involving numerical integration, and hopefully you'll look into them further, particularly higher order approximations. I'll be covering these in another series that I plan to launch in MATLAB, so be on the lookout for those. If you've got any questions, as always, feel free to email me. Let me know how I can improve these videos, and thank you for watching.